All right, so section 2.5, proving statements about segments and angles. Not a lot up here other than we are doing proofs. If you've heard anything about geometry, it's probably about proofs. Forget everything you've ever heard about it. It's like putting a puzzle together. I will give you the pieces and I will tell you how to put them together. You just have to follow the directions I give you and put them together. A two-column proof is how we're going to start. It is, remarkably, made in two columns. On the left goes the statement, and on the right, you write reason at the top. And then they get numbered 1, 2, 3, and 1, 2, 3. So you put what you know on the left side and why you know it's true on the right. And you usually start with something that's given to you and you're trying to prove something at the end. Now before we actually do any of these, I want to refer to this worksheet. If you haven't printed it off yet, you can find it in the resources, class resource page, or the link in the module. But you'll want to print this off and you'll want to keep this. So you save, save, save. This is a really, really, really helpful worksheet that we're going to go through together right now. So these are the pieces of the puzzle that you'll need to start use to put things together. So the first one, AB is congruent to CD. If you ever see anything like this, AB is congruent to CD, there's a really likely next step. Your conclusion, the left side of your column proof, would be that AB is equal to CD. What does it mean to be congruent? Well, to be congruent means that the lengths are equal. And how do we know that's true? The reason, the justification, is the definition of congruent. That's how we know that these are equal, is because I said, number one, they're congruent. If you see this, these are probably coming next in your proof. What about this? B is between A and C. What does that tell us? Well, if you ever have something like this goes back to chapter 1. If we know that B is in the middle of A and C, that means that this piece plus this piece is equal to the whole piece. Remember that? It was chapter 1, and it was called the segment addition. So what we know is that AB plus BC is equal to AC. And the reason? Segment addition postulate. You can add the two pieces to get the whole. The next one, M is the midpoint of line segment AB. What does this mean? If I told you that M was the midpoint of AB, what does that tell us about this picture? Well, that tells us that AM is congruent to BM. And how do we know that these two pieces are congruent? Well, because M is the midpoint. Your reason is the definition of midpoint. Our reasons are very frequently just a definition of something. So the next one, CD bisects, line CD bisects line segment AB. What does that mean about this picture? It bisects AB. Well, bisect means to cut into two congruent pieces, so that means that AM is congruent to BM. And if you rewind, I just said bisect means to cut into two congruent pieces. Means to, that means our reason is the definition of bisect. So notice, M is the midpoint, we use definition of midpoint. CD bisects, we use definition of bisect. AB is congruent to CD, we use definition of congruent. Lots of definitions. Angle R is a right angle. What does that mean? That means the measure of angle R is equal to 90. And how do we know that being a right angle means it's equal to 90 degrees? That's the definition of right angle. What about this? Angle ABC is congruent to angle DEF. Just like in line 1, what this means is that the measure of angle ABC is equal to the measure of angle DEF. And the reason is definition of congruent. Number 7, M is in the interior of angle LKN. This is very, very similar to number 2. Number 2 was the segment addition postulate. This one is going to be the angle addition postulate. The angle addition postulate says that you may add the two little angles and get the big one. So the measure of angle LKM plus the measure of angle NKM is equal to the measure of the whole angle LKN. Continuing on the back. Ray YW bisects angle XYZ. What does that tell us about the picture? Well, what does bisect mean? Bisect means to cut into two congruent pieces. So we need to put those congruent pieces here. Angle XYW is congruent to angle ZYW. And you'll see I said, what does bisect mean? That means this is the definition of bisect. All right, a couple more. Angle 1 and angle 2 are complementary. What did complementary mean? Well, complementary meant the measure of angle 1 plus the measure of angle 2 is equal to 90. And I'm going to start abbreviating definition, DEFN, definition of complementary. I started. What does it mean to be complementary? It means this. What about supplementary? Well, that means the measure of angle 1 plus the measure of angle 2 is equal to 180. And the reason is the definition of supplementary. Number 11, we don't use a lot, but it's here. AB is perpendicular to DE at point E. What does that mean? Well, going back to your notes, I believe it was section 2.1, we talked about perpendicular. Perpendicular means that they cross at a right angle. So that would mean angle AEB, or any of the other three that you need, is a right angle. And how do we know? Definition of perpendicular. Last two are very important ones. So, measure of angle 1 is equal to measure of angle 2, and the measure of angle 1 plus the measure of angle 3 equals 90. And we're using the substitution property is what they say. So you've done substitution before. Normally, like, you substitute an x into the equation. We did it in chapter 1. That means that everywhere there's an x, you replace it with something. So the question is, what can we replace? Well, you see here, measure of angle 1 and measure of angle 2 are equal. So we can basically choose if we want to use a 1 or a 2. Well, here is a 1. And because 1 and 2 have the same measure, this 1 can be switched to a 2. The rest of this statement stays the same. So because the 1 and the 1 are both there, we can take the 2 and put it in place for the 1. That's the substitution property. The transitive property. AB plus BC equals 5 and DE and EF equals 5. Do you see they are both equal to 5? They are both equal to something that is the same. And because they're both equal to something that is the same, that means the two left sides also have to be the same. That AB plus BC is equal to DE plus EF. Now I want you to keep this paper, keep it handy as we do a couple of proofs in your notes. The first example, we are given AC is equal to AB plus AB. We are trying to prove that AB is equal to BC. So where you start typically in a proof, you always start with the given. Always start with a given, and you end with what you want to prove. So if you look at this proof, line 1 is the given, and line 4 is what we're trying to prove. So even if you know absolutely none of the rest of the proof, you have no idea how to do proofs, you should at least get line 1, because that's the given, and you should get the last line, because that's what you're trying to prove. Everything in the middle could be an absolute mess, but you should at least start and end in the correct place. So let's see here. How do we know that AC is equal to AB plus AB? Well, we know that because they wrote it on our paper for us. They gave it to us. So your reason is actually given. It was given to us. That's how we know it's true. Now here's just a thought. If what's given is always here, your reason, your first reason, is always given. So this part, and the last one should always be correct. Now let's look at the next one. AB plus BC is equal to AC. AB plus BC is equal to AC. Look at your little train the brain paper. Is there anything that talks about AB plus BC? Is there anything here that talks about that? Number 2 says AB plus BC is equal to AC. And you see the picture ABC, and you see the picture ABC. They are very, very, very similar. So how do we know that the left plus the right is equal to the whole thing? Segment addition postulate. It's on the worksheet we just filled out. That's your reason. All right, now let's look at number 3. AB plus AB is equal to AB plus BC. Now in theory, as you start your proof, you should typically use the lines above it to get to the next step. We're trying to build like a bridge here, connect all the pieces. So can we somehow connect line 3, to the stuff above it? Well, look at the stuff above it. AC is equal to AB plus AB. AB plus BC is equal to AC. Do you see anything special going on with line 1 and line 2? Look. Right there. Do you see they're both equal to AC? Did we have anything on the Train the Brain worksheet where we had two equations and they were both equal to the same thing? Two equations and they were both equal to the same thing. This is the transitive property. That's what we're going to use. Because look, AC is equal to this, AB plus AB, but AC is also equal to AB plus BC. So that basically means we can connect them together with the ACs and totally ignore them. This is equal to AC, this is equal to AC, which means AB plus AB is equal to AB plus BC. We smush them together and we get rid of the part that repeats. The last line, AB plus AB is equal to AB plus BC. How did we get from line 3 to line 4? What changed? Well, it looks to me like that went away, and maybe like that went away. We lost an AB from both sides. So what allows you to remove something from both sides of the equation? That's called the subtraction property. That, ladies and gentlemen, is your first proof of geometry. Let's look at another one. The more of these you do, the better off you're going to be at manipulating these puzzle pieces. So you will get better, I promise. It may have seemed hard, but that was also the first one. So given, AB and CD bisect each other at point M. See, another given, BM is congruent to CM. And we're trying to prove that AB is equal to AM plus DM. So what do you think should go on line 1? Well, line 1 is always a given. Which given should we pick, the first or the second? I'm going to pick the first one first because it's first. AB and CD bisect each other at point M. Just copy it word for word off of your problem. Now let's look at what this actually says. AB and CD bisect each other at M. That's given. So that means that CM is congruent to DM. How do we know that bisecting means those two pieces are congruent? Well, looking back at your Train Your Brain, this really holds most of the answers. Here's the one that says bisect. And it shows two pieces are congruent, and the reasoning is definition of bisect. So here, what's our reason? Definition of bisect. Always, anytime you're given bisect, you're going to use definition of bisect immediately following it. All right, look at line 3. Line 3, the reason is given. So 3 on the left needs to be another given, which would be line 2. BM is congruent to CM. Now I said you typically want to use lines above it to get to the next line. So look at line 2. CM is congruent to DM, and line 3, BM is congruent to CM. Do you see anything that can connect those? What happens here? Well, look, this one has a CM, and this one has a CM, and we can actually essentially get rid of that and put BM is congruent to DM. If you look at the reason it says substitution property, this could also be transitive. I would probably make it transitive, but it's also technically substitution because instead of putting CM here, we're putting something congruent to it, which is DM. All right, line 4 to line 5. Line 4 has a congruent symbol and line 5 just has an equal sign. So it went from congruent to equal. What here on the Train Your Brain allows you to go from congruent to equal? Well, that's number 1. Look, they're congruent and now they're equal. Definition of congruent, that's our reason. Sometimes as you do these proofs, it's at some point oftentimes easier to kind of work backwards. If you've ever done mazes before, some people like to work from the front, some people like to actually go backwards and go the opposite way through the maze, and some people like to do a little bit of both. They go forward and they go backward and they see if they can meet in the middle. So for me, I kind of like to work both forward and backwards. So look at where we're trying to end up. We're trying to end up at AB equals AM plus DM. This setup right here looks a lot like this sort of thing, where you're adding two segments together to equal a whole thing. It really looks like the segment addition postulate. And if you look, number 6 says a segment addition postulate. So the question is, which one should we put here? What things should we be adding together here? Well, we already used CD in the proof with our definition of bisect. We're trying to end up at AB equals. So I'm thinking we use segment addition postulate here and say AB equals. And what does AB equal? AB equals AM plus BM. This piece plus this piece. So AB equals AM plus BM using the segment addition postulate. Now what changes between line 6 and line 7? AB is the same, AM's the same. That changed right there. How did we change from a BM to a DM? What did we do? Well, again, use what you have already up in your proof. Line 5. BM and DM are equal. So instead of BM, we plugged in the other one, DM. Which property on the Train the Brain allowed us to switch things that were equal? Number 12. Measure of angle 1 and measure of angle 2 were equal, so instead of measure of angle 1, we put measure of angle 2. That's substitution property. That's our reason, number 7. Because BM and DM are equal, we were able to switch from BM to DM. All right, last one. Given angle AEB is a complement of angle BEC, prove the measure of angle AED equals 90. All right, first off, let's do the easy ones. Number 1 has to always be what? A given. Angle AEB is a complement of angle BEC. And how do we know that? Another easier one that was given. We also know number 7, the very, very last line is always what you're trying to prove. The measure of angle AED is equal to 90. Now we don't know the reason yet. We just know the statement. So let's go back up to the beginning. Angle AEB is a complement of angle BEC. Okay? Back to train your brain. Number 9. 2 angles are a complement. That means their measures equal 90 degrees. They add up to 90 degrees. And the reason is definition of complementary. Now I probably wouldn't use definition of complementary. I would probably write it definition of complement, because they use the word complement instead of complementary. I would use the same word. But that means the measure of angle AEB plus the measure of angle BEC equals 90. The next one, angle AEC is equal to angle, or equals, these should all be measure. The measure of angle AEB plus the measure of angle BEC. So this one says this angle here is equal to this one plus this one. What was the thing on the train your brain that allows you to add angles like that? Number 7, angle addition postulate. The angle addition postulate and the segment addition postulate are some of the only ones that, honestly, how do you know to do this? Practice. They're the ones that I think are the hardest to see. All right, so let's look. Can we somehow use line 2 and use line 3 together to come up with something new? Line 2 says the measure of angle AEB plus the measure of angle BEC equals 90. Line 3 says the measure of angle AEC equals the measure of angle AEB plus the measure of angle BEC. You may notice here this part and this part are exactly the same. Exactly the same. Once you put the m's in there as they should be. Now what that means is that because that part repeats, this thing is equal to 90, but this thing is also equal to the measure of angle AEC, we can use the transitive property to remove the overlapped part. The part that's the same gets removed, and you end up with the measure of angle AEC equals 90. Next one. Again, these should have m's. The measure of angle AED plus the measure of angle AEC equals 180. This is one that was not actually on the train your brain. So let's look at the picture and see what we can figure out. Where is angle AED? AED, that's kind of like the left side. AEC is kind of the right side. So do you agree that the left side and the right side should add to 180. Yes. Why though? How do you know that they add to 180 degrees? You know it because they make a line. They make a linear, or they are a linear pair. They make the straight line right here. So we have to decide if it's like the definition of linear pair, or I guess in the dark here perhaps linear pair postulate. And perhaps we haven't officially introduced it as a postulate in that sense, but I'm going to put linear pair postulate. We know linear pairs make a line. Their definition technically doesn't say they add to 180. There's some postulate that says that. That's the linear pair postulate. We're almost there. A couple more blanks to go. So look at line 6. In order to use line 6, or to fill in line 6, let's look at 4 and 5. Is there something we could do to lines 4 and 5? Right there. Some connection here. Well, look, this one has, line 4 has a measure of angle AEC, and line 5 has a measure of angle AEC. Because they have that thing in common, we can actually do either 12 or 13. We have to decide which one's appropriate here, though. So the transitive property is when they're both equal to the same thing, and you get rid of that middle thing. The substitution property is when you're changing something kind of in the middle of the equation. So here, if we change this measure of angle AEC to a 90, see, it's in the middle of the equation. This is a substitution. The substitution property. And what we're going to do, instead of writing measure of angle AEC, we're going to write 90. Instead of measure of angle AEC, we wrote what it's equal to, which is 90. All right, one more blank. What happens from line 6 to line 7? It kind of looks like the 90 moved from the left side to the right side and the 180 disappeared. But what actually happened? How did they get the measure of angle AED by itself? I bet they did that. Minus 90, minus 90. Reason? Subtraction property. At this point in time, you should have enough examples. Use the train the brain and give those proofs a try.